Hi students, MCQ number 7. The electric field that can balance a deuteron of mass 3.2 into 10 power minus 27 kg has to be found. So very simple question. You assume this is a deuteron. So heavy hydrogen only is called a deuteron. Its symbol is 1H2. So the mass of the deuteron is given here, 3.2 into 10 to the power of minus 27 kilogram. It is having a charge number of 1 unit, is it not? 1 electronic charge or 1 charge of a proton. Therefore, its charge must be equal to 1.6 into 10 to the power of minus 19 coulomb. And the value of G has to be assumed as 9.8 meters per second square. Okay. Now two forces are acting on the deuteron. One is the gravitational force. That force is Fg. That is equal to mass into acceleration due to gravity. It is being balanced by the other force called electrical force. So the electrical force is equal to charge into the electric field, magnitude of the electric field. So I am going to equate these two because they are being balanced. So Q into E, the electrical force must be equal to M into G, or the electric field is now equal to M into G divided by Q. So I am going to substitute M, Q and G. So M is 3.2 into 10 power minus 27 into 9.8 divided by 1.6 into 10 power minus 19. Now 1.6 into 2 is 3.2. So this can be cancelled 2 times. So this is 2 into 9.8 into 10 power minus 27 into 10 power plus 19. So denominator minus 19 will become plus 19 in the numerator. So that 2 into 9.8 is what? 19.6 into 10 to the power of minus 8 Newton per coulomb. So we have got an value for the electric field as 19.6 into 10 power minus 8. So option B must be the correct answer. Okay. Therefore, option B is the correct answer. So this is a very simple numerical problem, but has been asked many times in the previous competitive exams. I hope you must have understood them fine.